Hello there. Remember the last time you did your grocery shopping? What were your protein choices? Are you a meat lover, vegan, or a flexitarian? Why does your choice matter, you ask? I'm glad you asked. By 2050, we have to feed 9 billion people. And the animal-based protein demand is expected to double by then, according to the FAO of the United Nations. Can we completely rely on animal-based proteins? Well, no, because it's not sustainable in the long run. Faba beans could be our next soy. They are high in protein, they are gluten-free, they are GMO-free, they are also a good source of essential amino acids. However, faba beans are underutilized for human consumption, mainly due to the presence of flatulence-causing compounds and anti-nutritional factors. So, there is a need to isolate faba proteins which are minimal in these negative factors. Conventional wet fractionation methods for protein isolation are more energy and resource intensive and could influence the native functionalities of the proteins. A more sustainable alternative is dry fractionation, which could only lead to relatively modest enrichment in protein content. What if we could develop a hybrid fractionation method that employs both dry and wet fractionation techniques to isolate clean label proteins by overcoming these challenges? The most exciting part, this is exactly what I am working on at the University of Alberta. We explored the macronutrient distribution pattern across faba beans by sequential pooling. We found that faba proteins were concentrated in the outer layers, which was offset by the inverse trend of starch content. Taking advantage of this distribution, we produced a protein-enriched fraction which was then subjected to water extraction to isolate the proteins. We were also able to isolate the starch and concentrate the dietary fiber as byproducts. You might wonder how this was possible. The naturally present minerals could have had optimal contribution in releasing the salt-soluble proteins from the flour matrix. In a nutshell, we started off with a 30% protein content. Then, we employed hybrid fractionation to isolate high-quality proteins. What if we can create plant-based alternative products that look, taste, and nutritionally benefit similar to liquid eggs? That's the final outcome of our research. Thank you so much for watching. Bye.